Hello mathematicians, thanks for joining me today as we go through some more calculus on parametric equations. Our goal today is going to be to find the tangent line to the equation given parametrically by x of t is t minus sine of t and y of t is 1 minus cosine of t. And we're going to find the tangent line when t is pi over 2. Alright, as we get started on this, before we dive in and actually calculate things, what we want to do is we want to find what it is that we're actually trying to find. And so in order to do that, we're going to provide a graph, and we're going to look at what is a tangent line graphically. And so we should graph the equation given by x of t is t minus sine t, y of t is 1 minus cosine t. So now how are we going to do that is, well, we have lots of curve sketching techniques if we're given just the function y in terms of x, but when we're given parametric equations, we don't have a lot of techniques so far built up in calculus to help us with that. So really we fall back onto just, well, we're going to plot some points and play connect the dots with those points so that we can get at least a rough sketch of what's going on. Now if you don't want to do this by hand, you can also use a calculator and you can get out, well, let's just at least get a rough sketch of what's going on. So as we do that, I'm going to pick some values that are going to be easy to calculate just to give me a few points. Now since I'm calculating cosines and sines, I know that calculating cosine and sine at, say, 0 or pi or 2 pi are relatively easy, so those are the points I'm going to pick. So I'm going to start off with 0, and if I plug 0 in for t, notice that I get 0 minus sine of 0 is 0 is x is 0, and 1 minus cosine of 0 is 1, therefore 1 minus 1 is 0, so I'm going to have the point 0, 0 on my graph, and I'm just going to plot that in. Then I'm going to move on and say, okay, well, what about pi? So if I plug pi in for t, I get pi minus sine of pi is 0, so that's just pi for the x value. And 1 minus cosine of pi, well, cosine of pi is negative 1. So 1 plus 1 is 2, and so I'm going to have the point pi 2 in my graph. And then I can go through again and say at 2 pi, I'm going to get 2 pi minus 0 for x. Now I'm going to get 1 minus 1 is 0 for y. And so I have the point 2 pi comma 0. And so again, I'll plot that in. Just to give me a little bit more view of what's going on, I'm going to also plug in negative pi, at which point I'll get negative pi minus 0. 1 minus cosine of negative pi. Cosine of negative pi is negative 1, so I end up with negative pi 2. And if I plug in negative 2 pi, I'm just going to get x is negative 2 pi, y is 0. And so now at least I have some points that I can play connect the dots with. And if I do this, what I end up with is that the graph of this function is going to look like this. Now that's roughly, it's not exact, but it is a good indication of what's going on so that we can use that to say, well, what we're trying to do is find the tangent line to this function when t is pi over 2. Now, since we need to find the equation of the tangent line at t equals pi over 2, we're going to also draw on the tangent line so that we know roughly what to expect when we get our answer. And the idea is that if I let t equal pi over 2, I get pi over 2 minus sine of pi over 2 is, well, pi over 2 minus sine of pi over 2 is 1. Pi over 2 minus 1 is approximately 0.5, because 3.14 divided by 2 is about 1.5 minus 1 is 0.5. So again, this is an approximation, it isn't exact, but it gives me an idea of where to look. And then I plug in pi over 2 for this, and I get 1 minus cosine of pi over 2. Well, cosine of pi over 2 is 0, so 1 minus 0 is 1. And so what we're looking at is the point where y is 1, and x is approximately 0.5. And so that would be approximately the point that I would be getting. So I'm going to graph that in there as the point I want to draw the tangent line at. Now, how do I draw the tangent line? Well, the idea is that the tangent line is the limit of the secant lines. So I'm going to pick this point, and I'm going to pick some other point on the function, say here, and I'm going to visualize what that line is going to look like. And then what's going to happen is, instead of sticking with that one, I'm going to imagine, okay, if I let this point get closer and closer to this line, what's going to happen to each of the secant lines? And as I draw my secant lines, as the point gets closer and closer, what I can imagine is that I end up with a tangent line that looks approximately like that. Alright, so now that we have a visual representation of what we're trying to do, we're actually going to go through and calculate these things. And so since we want to find the equation of the tangent line at t equals pi over 2, what we first need to remember is, what is the equation of a line? Well, in order to do that, I'm going to use point slope form. So I'm going to say y is m times x minus x naught plus y naught. And so in order to find the equation of a line, I have to find my slope, and I have to find the point x naught, y naught. Now, in this case, in order to find my x naught, y naught, what we saw was that we had to find the x value at the time t equals pi over 2. So what we're really doing is we're saying x naught is going to be x of pi over 2, and so we're going to plug pi over 2 into here, and I get pi over 2 minus sine of pi over 2 is 1, so my x naught will be pi over 2 minus 1. Then my y naught again will be y of pi over 2. So I'm going to plug in pi over 2 for t, and I get cosine of pi over 2 is 0. So I get 1 minus 0 is just 1. And so I find my x naught and my y naught by plugging the corresponding t value into both x of t and y of t. Now that I have my x naught and my y naught, I have to find the slope of my tangent line. And so what I need to remember is that the slope of the tangent line is just defined to be the derivative of y with respect to x. Now in this case, notice that we're not given y as a function of x, so we can't find the derivative directly. So instead what we need to do is we need to work with this a little bit so we can end up getting out dy dx. So in order to find the slope of the tangent line, we have to find dy dx. And what we're given though is that we're given x as a function of t and y as a function of t, but we're not given y as a function of x, so we just can't find the derivative directly. Instead what we need to do is we're going to end up using the chain rule, and what we can say is that, well, y is a function, so what I can do is I can plug x of t into y, and now I'll have a new function where y is a function of x of t, and what I can do is I can say, well, let's find the derivative of y of x of t with respect to t. And then what I'm going to get is dy dt, and so what I need to know is that, well, since y is a function of x is a function of t, I can use a chain rule where my inside function is x, my outside function is y, and what I get then is that this is going to be the derivative of the outside, which is dy, with respect to the inside, which is x, times the derivative of the inside, which is x, with respect to t. What I get is dy dt is dy dx times dx dt. Therefore, what I can do is I can say that, well, if dy dt is dy dx times dx dt, we indeed can get that dy dx is just going to be dy dt divided by dx dt, because I can solve for dy dx by dividing by dx dt. And so if I want to find the derivative dy dx, what I can do is I can find the derivative of y with respect to t, the derivative of x with respect to t, and then take the quotient of the two. So now as we continue, the point is that we just found that dy dx is just dy dt over dx dt, so we have to find dy dt and dx dt. So to find dy dt, we just take the derivative of this with respect to t. So the derivative of 1 is 0. The derivative of negative cosine of t is sine of t. So we get dy dt is just sine of t. If we look at the derivative of x to t, we get, well, the derivative of t is 1, whereas the derivative of sine is cosine. So the derivative of negative sine is negative cosine. So what I end up with is dx dt is just 1 minus cosine t. If we combine that together, what we get is dy dx is sine of t all over 1 minus cosine of t. Now that we've found dy dt in general, what we need to do is we need to find it in the situation that we were looking at. And since we were trying to find the tangent line when t was pi over 2, what we would find is that dy dx when t is equal to pi over 2 is equal to sine of pi over 2 over 1 minus cosine of pi over 2. And since sine of pi over 2 is 1 and cosine of pi over 2 is 0, what we get is that the slope of our tangent line will be precisely 1. Alright, so now just reminding ourselves of what we had is that we said that the equation of the tangent line will be the equation of the line. So we needed to find m, x naught, and y naught. We found x naught was x of pi over 2, which is pi over 2 minus 1. Y naught was y of pi over 2, which was 1. And we said our slope was dy dx at pi over 2, which we also got was 1. Therefore, if we combine this all together, what we get is the equation of our tangent line is y equals 1 times x minus pi over 2 minus 1 plus 1. So now if you'd like, you can simplify that, but I'm going to leave that as is and just say that that is the equation of our tangent line. Now, if we'd like to go back, we can say, well, we have our picture from earlier, and what would 1 times x minus pi over 2 minus 1 plus 1 look like? Well, if we graph this compared to our tangent line that we graphed just visually, these would look very similar. And so I encourage you to do that on your own, to go back and check your work to make sure that this makes sense. Thank you for joining me today as we work through some calculus problems. I hope you learned something, and I hope that helps out with your studying. If you did enjoy it and you learned something today, make sure to hit that like button and subscribe to the channel.